Hi, welcome back to the Enzyme Kinetics Derivation Part 2. So in the last video, we kind of derived our equations and formulas halfway from the quasi-steady state assumption. Now before we continue, let's just tidy this up, yeah? And we're gonna make two, two variables. We're going to combine these all these k's into some two variables so that's easier for us. So let's take km. We just have a variable called km equals to k1 plus k2 over k1. I believe that has to do with some of the quasi-steady state. I mean, it's mostly to do with the first reaction, the equilibrium, and second, we're gonna call kp equals to k minus 1 plus k2 plus k minus 2. Okay, we're going to substitute these. Okay, we're going to substitute these into our equations here. So that it's a lot easier to derive. So let's just go and do that. So we have ES equals, I'm just going to do it without the 1 and minus 1. Okay, so let's just have S over Km plus P over Kp. Yeah. Okay, and that will be over 1 plus, again, S over Km plus P over Kp. I can see that's a very simple way of presenting ES, and that's a lot neater than say something like this. So let's just put E naught there and then we are done. So we'll have ES equals this. Now can we have the concentration of E in a very similar manner? Well, why not? So let's take a look, maybe perhaps back at our enzyme balance or something like that. I mean, there are a few ways we can go about doing this. We can substitute ES into here and we find E, or we can substitute ES into here and find E as well. So there are two ways of doing it, basically. And I suppose both should end up with the same result. It's just a matter of which is actually easier to do. Yeah. And just the lighting, oh, it's hot. The light's hot. And just to make it a bit easier for us to see. And let's continue. So let's try the substitution into the enzyme method. Let's see where that leads us. Substitution into the enzyme balance. See where that ends up. Hopefully it ends up okay. So let's try this. We're going to substitute this here. So let's just try that. So we have E naught equals to concentration of free enzyme E plus the concentration of enzyme substrate complex. So that is substituted from here. So that is E naught into all this, whatever this is. So S over Km plus P over Kp over 1 plus S over Km plus P over Kp. Okay. So again, I'm going to shift this to the left. And we should get our expression for E. So I'm going to use the blank space here. E naught equals to, so I have a 1. So I have 1 minus whatever this is. So 1 minus S over Km plus P over Kp over 1 plus S over Km plus P over Kp. So this multiplied by this will give you E. Okay, no problem. And now we can substitute these two results, this E and E naught, back into our first equation. Let's see where that brings us. I'm going to turn this paper and let's look at our first equation, equation 1, which is V equals to dP dt into K2 into ES minus K minus 2 E into P. Okay, so as written previously, ES will be this box here. So let's just write K2, and we have E naught, and we'll have whatever is in this box. So it's S over Km plus PE over Kp over 1 plus S over Km plus P over Kp, right? And minus K minus 2 P, and we're going to substitute that E here, concentration of free enzyme. So I'm going to write this whole thing right here. So let's just start with the E naught first. E naught 1 minus S over Km plus P over Kp over 1 plus S over Km plus P over Kp, close bracket here, and we're partially done. So anyway, I'd like you to notice something. So K2 into ES is the rate. When ES equals to E naught, that is the maximum rate of this. So what does this mean? The concentration of ES equals to the concentration of E naught. This is the total concentration of enzyme. If all of it is forming this enzyme substrate complex, that means that the rate here is the maximum rate. So V will become the Vmax. So I mean this rate here will become maximum. Let's just call that maximum Vs max, because that's the rate of reaction of the substrate at its maximum. So let's just call it Vs max, which is K2 into E naught. So when this equals to E naught, this whole term will equals to this term, that is the Vs max, the maximum rate of the conversion of the substrate to product. So we just call it Vs max. So that's S over Km plus P over Kp over 1 plus S over Km plus P over Kp. I'm going to want to do the same for this. So this and this are going to combine. I'll just call that Vp max, because that's this into this, or rather, this into this will be the maximum rate. Oh wait, no, not yet. Vp max will be the backward rate of reaction here. So that represents the maximum rate of conversion from product back to the substrate. So Vp max equals ES K minus 1 into ES at ES equals to E naught. Okay, So anyway, we'll just do that later because now it's not quite convenient to do any of that yet. So let's do something else. First, we want to convert some of the pluses into the, we want to get rid of the negative sign so as to make life easier for ourselves. K minus 2 t into E naught. Okay, so we'll have this S over Km plus P over Kp over 1 plus M plus Kp minus 1. So I'll start cleaning all of this up. Okay?
Shall I put the thing in the ABC inside the soup already?
Okay.
Now?
Okay. Don't worry about that. Okay, edit out later. Anyway, so got to get this to have a common denominator. So let's have a common denominator first. Okay. So Vs max S over Km plus P over Kp 1 over S over Km plus P over Kp plus K minus 2 P into E naught, and we'll have this 1 over S Km plus P over Kp 1 plus, oh sorry, there's no 1 plus on top. So okay, what I've done is that I've just multiplied this into the numerator and denominator. So numerator and denominator. So this whole thing here is the minus 1 term. And now I can start cancelling things. So let's cancel this, we'll cancel this, and we cancel this too. Okay? No problem. And what will we have remaining? So we have the Vs max, okay, S over Km plus P over Kp over 1 plus S over Km plus P over Kp plus K minus 2. So P into E naught. Okay, over 1 plus S over Km plus P over Kp, the whole thing times negative 1. Alright, so we're getting somewhat close-ish, but not quite close yet. So probably want to continue this derivation in the next video, the part 3. So this is the PDT, which is just the V. You just call it V. It's the Greek letter which I don't know how to pronounce. I don't want to know how to pronounce. I not say don't want to know, but I just don't know how to do it now. Okay, but this V equals to the Vs max times all of this plus the K2 into P into E naught over all of this, the same denominator, times minus 1. So when we come back, we want to clean up the numerator, and pretty much we are more or less done with the derivation. So see you in the next video. Bye.